Math 2, 1.3 notes in 7th period on Thursday. Wonderful. What we talked about last time, things that you were supposed to remember, what does adjacent, what does vertical mean? We talked about how adjacent were ones that were next to each other, sharing a side and sharing a vertex. Vertical angles, on the other hand, were across from each other, like 1 and 3 and 2 and 4. We also said that you had to know what the names of each of these things were. So I gave you a little chart with numbers here so that you could know what were consecutive interior angles, or which ones were alternate interior, alternate exterior angles. These are the names of those types of angles or angle pairs. But then the last thing that we talked about, the thing that you were going to do the most amount of work on, is whether they add to 180, and there should be a little degree symbol here, whether they add to 180 or whether they are congruent, which means equal and the same size and same shape. The easiest thing you could do is to look at your angle pairs and kind of copy all of the angles that are vertical and small angles, acute ones, let's go with that, and put those are all going to be the same. All the red odd angles are going to be congruent to each other. Switch colors to blue. Let's go to green. All of the green even angles are going to be equal to each other. They're obtuse and they're the same as each other. They're going to be equal in measure. So the hardest part is that you're going to have to say when you have a red angle and a green angle together, they're going to add up to a straight line, and a straight line has 180 degrees. When I look at a protractor, I'm going to throw this protractor on my screen. You can see the protractor. When you put this angle together, which just so happens to be about 72 degrees, 0 all the way to 72 degrees roughly, maybe 71. The other angle, the green angle, is 108 degrees. They are supplementary because they add to 180. So like measuring this is like 72 degrees and this is about 108 degrees. These together are supplementary. I'm hoping that makes sense. I don't know what happened to my screen. What happened there? Oh man, that's not good. Let me press undo. How do I do undo here? Let's go here. Control Z. That didn't work. Undo, undo, undo. There we go. Got it back. Real life. So, did we already do this question? The answer for number 5 was consecutive interior. It's doing some funny stuff. I wonder if it's because I'm using green. Oh, look at, there you go. Did we already do number 7? All we did was plug in the negative 50 in to the n, and we added 12 to it so that we could plug in these two things in right here and there, and we got that it was 100 plus 12, which was 112. And then my computer's doing some funny things right now. I don't know why that just did that. Oh, look at it's doing some weird things. 112 degrees here. Across from it, its vertical angle has to be 112 as well. This is supplementary to that. So if 112, what adds to 180 would be 68. Is that what you guys got? And then the acute ones will be the same as well. So I think we got all the way to 7. I don't know if we got to 11. Did we get to 11? Yes or no? Do you have 11 done for you guys or no? Yeah. Okay. For anybody who needs it, the obtuse ones are the same when they are parallel. We did 5/9 x plus 20 was equal to negative 1/3 x plus 16. And it got a little bit funky, so we used the calculator. We added 1/3 x, added 1/3 x. So 5/9 x plus 1/3 x. I'm going to use the calculator for that. 5/9 plus 1/3 is 8/9 x plus 20. I'm going to subtract 20 from both sides. Equals negative 4. And the opposite of times by 8/9 is to divide by 8/9. Or you can just multiply by the reciprocal. Same thing. So I'm going to take negative 4 and divide it by my answer. For those of you who did not write it down last time, there it is for number 11. The only other examples that I have for you is this number 13. And I need to warn you about something about number 11 versus number 13. What number 11 does that a lot of you forget about is that it gives you what is the value of x. It asks you to find what is this value that will make these two things the same. On your test, when we get to it, most of the time on the test, you will never just be asked for what x is. You will always be asked to take that value, plug it back in, and find out what that angle would be. That's what this question does so much better. Number 13 is a way better example. It's how most of your tests will be written when you get there in a couple of weeks. So when you look at number 13, you have two choices to make about these two angles. They are either equal to each other or they add to 180 degrees. Do you know which one it is? If you think you know, tell the person you're sitting next to, do they add to 180 or are they equal? I heard a lot of you say add to 180. You are correct if you said add to 180. So what does that mean? That means you take 13x plus 9 and you are going to add 12x minus 4. And that sum should equal 180 degrees. So when you add these together, 13x can only add to the 12x. 13x plus 12x is 25x. Nine minus 4 is plus 5. So we're going to subtract 5 from both sides. And since 25 is multiplying the x, we'll divide by 25 on both sides. I'm going to use my calculator to figure out what 175 divided by 25 is. And we find out that x is equal to 7. What I like about this question is that it has you take the 7 and say, well, what is it when you plug the 7 in? So what we're going to have to do off to the side is we're going to have to do 13 times 7 plus 9. And 12 times 7 minus 4. 13 times 7 plus 9. I'm going to use my calculator for that. "12 times 7 minus 4 is," and that should make sense because we said these two angles needed to add to 180 degrees. I'm going to stop your notes right there.